Right, in this video, we continue to discuss about how the CSS is formed in the cavity. And in the last video, in the part 1 and part 2, I already introduced to you the structure of the cavity present inside the central nervous system. Here we have lateral ventricle, here we have third ventricle, and now to here we have the fourth ventricle. And this structure we call choroid plexus. And this choroid plexus present inside the CSF cavity is produce the CSF, right? And you know this structure already. So this structure, what we call choroid plexus. So let me draw again the structure of choroid plexus. Then you will see how the CSF is forming inside the cavity. And now you see here, this is, for example, this is the brain substance. The brain substance, right? And of course, outside the brain substance, there is a layer here. A very soft layer is very closely to the brain substance. And you know this already, this layer we call biameter. Right. And here is for example, here is the cavity inside. Cavity, right? For example, this cavity I will draw here. And this cavity, you know, outside something go in. And what is that something go in? Something go in here. We have the artery. This we call choroidal artery. Go inside the cavity. Choroidal artery, right? And choroidal artery, when they go inside this cavity, they will make the here we call the capillaries. We make the capillaries like this, right? And then after that, the blood will go out. And this we call, from here I should draw another color. This we call what? So the blood will go out through the choroidal vein. This is the vein, right? And this is the artery. And this is the capillaries. And then, of course, this biameter, let's go in and they line with this vascular system, this, right, like this. And then here is the cavity, and this cavity, let me make it bigger, then you can understand easily. Yeah, big like this. And as you know that on the cavity in the central nervous system is covered or lined by one type of cell, and that cell is a ependymal cell. For example, here I told you already on this, on the surface of this cavity all are lined by ependymal cell, right? So here, of course, here is a ependymal cell surrounding here. And this ependymal cell here, also, let me make another color, then you can see. This is the ependymal cell here, right? And then, okay, I will draw on the surface the cell. The shape of the cell is look like this, right? And then now here is the cavity where the choroid plexus will make or secrete the CSF. And how it make? Now, first thing, on this ependymal cell, there's a lot of sodium. What is that? Sodium. There are a lot of sodium. This sodium. And the sodium from the ependymal cell here will send out. And how they can send out? On this cell, they have the transporter. What they have? Here they have the transporter. Like the hole, right? Transporter. And this look like the hole like this. hole like this. The hole like this. Because sodium cannot cross or travel throughout this membrane. So that's why they need a transporter. It looks like a hole. This transporter can send something out and can something in and out. Something go inside or something will go outside through this transporter. So there are lots of sodium transporter on the ependymal cell. And from here they will send out. They will send out or they will release what? Sodium. So sodium, right? So sodium out. And you know that sodium is a positively charged, right? And this sodium, when they go out, they will attract something go with them. And what is that thing? And something here go from inside, sodium inside, positively charged, right? Positively charged. And then they will attract something out with them. And what is that? That is chloride. You know, sodium with chloride. Yes, chloride. I will write here. Sodium and with chloride go to the go out the transporter, right? And then go to the cavity. So now in this cavity, what we have? We have sodium and then chloride. And you know that when sodium and chloride come out through this transporter, and what happened in this area, we call that choroidal area here. And then in this area, the osmotic pressure will increase. You know, osmotic pressure. So now, because of sodium and chloride come out, and it make this area or this cavity, and in this cavity, osmotic pressure will increase. Osmotic pressure means now they have the tendency to absorb water, to take water. So that's why they will pull out the water, right? From here, they will pull out the water to this cavity. Now, there's one more thing come out with sodium and chloride, and that is H2O, water, right? So now you see sodium, chloride, and water together from they come out from the ependymal cell through this transporter. Now, one more thing. Okay, we need one more thing from the artery, from the blood. Of course, this artery will bring the blood go inside this cavity. And what happened? Here also on this cell, on the surface of these cells, there are another transporter also. And this transporter is, okay, so I just draw one. This transporter is I will draw one more here. This transporter is a glucose transporter. What is that? Glucose transporter, right? So why we need transporter? Why cell needs transporter? Because the glucose molecule is very big, right? And then they cannot pass through the membrane of the cell. So they need something. They need a transporter here. So here on the ependymal cell, here we have a lot of glucose transporter. So now the glucose in the blood can go through, for example, this is glucose. And this glucose will go throughout and then will go inside this cavity. Right? Now what we have right now. So choroidal, I will remove this. Now what we have? CSF, now we have sodium plus chloride. What? Water. And what else? And glucose. glucose. Yeah. So this is the component of the CSF, right? The cerebrospinal fluid, right? Then one more thing, but you have to remember one thing. So the level of the concentration or the level of the glucose in the blood is higher than the concentration of the glucose in the CSF, right? This means the level of the glucose in the blood is higher than. Here is a less than, here is a higher than. Right. Now, for example, if the glucose or the level of the glucose in the blood is 100 milligram per dl, for example, 100 milligram in on per dl, right? And then here 100 milligram per dl, and then the level of the glucose in the CSF cavity is only 2/3 of that. How many? 2/3 of that, around 66 milligram per dl, right? So this is the this way the CSF is formed in the cavity through the choroid plexus, right? And then one more thing you need to remember, inside this in this cavity, the CSF here, we have potassium. Potassium. Right, potassium. So the CSF will send something back to the blood through the transporter. Then the potassium will go back to the blood, right? So potassium also here. Potassium, right? Now that's why you need to remember that the potassium, the level of the potassium in the CSF is less than the potassium in the blood. Why? Because the potassium come out or go back from the CSF to the blood, right? So this is the way how the CSF is make or form or secrete in the CSF cavity. So I hope you understand the importance of this, and thank you so much.